Nobody expected this. Tesla just confirmed a $14,990 EV launching before year's end. That's half the price of a Model Y. Elon Musk says it'll be available in many U.S. cities within months, and insiders claim production could outpace Model 3 and Model Y combined. But here's what's truly shocking. Leaked specs reveal aluminum-ion batteries, 300-mile range from just 53 kilowatt-hours, and full self-driving hardware standard. How is Tesla hitting this price when even China's BYD struggles below $12,000? What features did they cut to make this possible? Let's dive right in. The timing of this announcement isn't coincidental. BYD has been absolutely crushing Tesla in global sales, flooding markets with EVs starting at $12,000. The sales numbers don't lie. BYD sold more electric vehicles than Tesla in 2024, and that gap keeps widening. Musk watched China's automakers prove that millions of buyers don't need premium features. They need affordable access to electric mobility. So why did Tesla wait this long to respond? And what changed internally to make a $15,000 Tesla suddenly possible? Here's where it gets interesting. The original Model 2 project targeted $25,000 to $30,000. Every automotive analyst, every Tesla blogger, every Wall Street firm predicted Tesla would land somewhere in that range. Then Musk apparently walked into a production meeting at Giga Texas and said, "That's not good enough." Internal sources claim he demanded the team find a way to cut costs by nearly 50% without turning the car into a penalty box on wheels. That's when engineers started exploring truly radical solutions and stumbled onto aluminum-ion batteries. But before we dive into the battery breakthrough, let's talk about what Tesla actually cut to hit this price. The Model 2 uses fabric seats instead of vegan leather. There's no heated seats, no panoramic glass roof, and the acoustic glass is single pane instead of double. Ambient lighting drops to one color, and the speaker system gets simplified. On paper, these sound like painful sacrifices. Yet here's the twist. Tesla kept the entire full self-driving hardware suite. Every camera, every sensor, every processing chip. All standard equipment. Why would Tesla sacrifice comfort features but protect autonomy hardware that costs thousands per vehicle? The answer reveals Musk's actual strategy. This car isn't designed to be your forever vehicle. It's designed to be your entry into the Tesla ecosystem and eventually their robotaxi network. Tesla needs millions of affordable vehicles on the road running FSD software, collecting data, proving the technology works. The Model 2 is a Trojan horse. You think you're buying cheap transportation, but you're actually buying into Tesla's autonomous future. Think about it. What happens when your $15,000 Tesla can earn money as a robotaxi while you're at work? Now, let's address the technology that makes this price possible, because this is where things get genuinely wild. For the past 15 years, every EV battery has relied on lithium. Tesla used it, BYD uses it, every major automaker depends on it. Lithium prices swing violently. Supply chains are controlled by a handful of countries, and the material itself isn't getting cheaper. Musk apparently told his battery team, "Find a way to eliminate lithium entirely." Most engineers would have laughed, but according to leaks from people inside Tesla's battery division, they actually did it. Aluminum-ion batteries work on completely different chemistry. Where lithium ions carry one positive charge, aluminum ions carry 3. That triple charge allows significantly more electrons to flow, increasing energy density while reducing material costs. Early prototypes are hitting 500 watt-hours per kilogram. nearly double what current lithium cells achieve. But here's the part that sounds almost too good to be true. Reports claim Tesla's 53 kilowatt-hour aluminum-ion pack delivers over 300 miles of range. Do the math. That's better efficiency than any Tesla currently on the road, in a battery that costs roughly $2,000 less than an equivalent LFP pack. If these numbers hold up in production, Tesla just leapfrogged every EV manufacturer on the planet. BYD can't match this. They're locked into lithium supply chains they've spent billions building. Legacy automakers are even further behind. They're still trying to master lithium production while Tesla potentially moves to an entirely different element. This isn't just a new car announcement. This is Tesla potentially rewriting the rules of EV battery technology while everyone else is still playing the old game. But let's pump the brakes for a second and address the skepticism. Can aluminum-ion batteries really deliver on these promises? The technology exists in labs, but scaling it to mass production is a completely different challenge. Aluminum-ion chemistry has traditionally struggled with cycle life. The number of charge cycles before capacity degrades significantly. Tesla would need to solve this problem to offer their standard 8-year, 120,000-mile battery warranty. Have they actually cracked it? Or is this another Musk timeline that slips by 2 years? The December reveal will answer that question definitively. There's also the production angle. Musk claims Tesla will manufacture thousands of Model 2s per day, potentially exceeding Model 3 and Model Y production combined. That's an insane target. The Model Y became the world's best-selling vehicle by hitting roughly 1.2 million units annually. Musk is essentially claiming the Model 2 could match or exceed that within its first full year. Where's that production capacity coming from? Giga Texas is already maxed out. Giga Shanghai focuses on Model 3 and Model Y for Asian markets. The only logical answer is a massive expansion we haven't seen announced yet. Or Musk is dramatically overselling what's actually achievable in 2025. Here's another angle nobody's talking about: Tesla's Optimus robot development. Why mention humanoid robots in a car video? Because the two projects are directly connected. Tesla is pouring billions into Optimus specifically to automate vehicle production. The latest Optimus prototypes can run at 7 miles per hour, manipulate small objects with human-like precision, and work continuously without fatigue. If Tesla deploys thousands of Optimus units inside Giga Texas, they could theoretically hit those aggressive production targets Musk keeps promising. The Model 2 might be the first Tesla built primarily by robots, which would explain how they're cutting costs so aggressively. The market implications are staggering. At $14,990, the Model 2 undercuts the average used car price in America. You could literally buy a brand new Tesla with full warranty and FSD capability for less than a 3-year-old Honda Civic. What happens to the used car market when that becomes reality? What happens to traditional automakers still selling $40,000 EVs? Ford, GM, Volkswagen, they've all invested billions in EV platforms that can't compete at this price point. If Tesla executes this, we're not just watching a new product launch. We're watching the potential collapse of the traditional automotive business model. So here's exactly why Tesla can hit $14,990 when everyone predicted $30,000. It's not just about cheaper batteries or simplified interiors. It's about Tesla building the foundation for their robotaxi network, while legacy automakers are still figuring out how to make profitable EVs. Every Model 2 on the road becomes a data-collecting, revenue-generating node in Tesla's autonomous future. That's the real disruption. December's reveal will answer the biggest question: Can aluminum-ion batteries actually deliver 300-plus miles in mass production? Or is this another Musk timeline that stretches into 2026? If Tesla pulls this off, we're watching the exact moment affordable EVs become cheaper than used gas cars. That fundamentally reshapes transportation. And this is just the beginning. When Optimus robots start building Model 2s in Giga Texas next year, production costs drop even further. What happens when Tesla hits $12,000? $10,000? The entire automotive industry is about to find out if they can survive what's coming. Here's the real question. Would you buy a $15,000 Tesla that can earn money as a robotaxi, or wait for Optimus to drop below $20,000? Drop your thoughts below. This is Tech Revolution, and we break down the tech that's actually changing the world. For the latest on Tesla's December reveal and Optimus production updates, you know where to find us. The future of transportation just got a price tag, and it's shockingly affordable. It's finally here. Tesla's $850 motor just landed, and it's powering the $15,000 Model 2. While Toyota and BYD still spend $3,000 per motor using rare earth magnets, Musk cracked the code with recycled carbon fiber and common iron. But here's what's truly shocking. This budget motor spins at 25,000 RPM, hits 99.7% efficiency, and outlasts gas engines by 1.2 million miles. How is a motor this cheap more powerful than what's in a $100,000 Plaid? Can it really make EVs cheaper than Corollas? Let's dive right in. Here's the truth nobody talks about. For decades, every electric motor hit the same physical ceiling at 16,000 RPM. Push beyond that speed, and the rotor literally tears itself apart from centrifugal force. Metal components expand, warp, and overheat until the entire system fails. This wasn't a design flaw, it was physics. So how did Tesla break through when Ford, GM, and Toyota couldn't? 4 years ago, Tesla engineers wrapped the Model S Plaid rotor in a carbon fiber sleeve just 0.1 millimeter thin. This sleeve handled 7,000 megapascals of tensile strength, 5 times stronger than steel, while enduring 200 degrees Celsius without breaking down. The result? 20,000 RPM. But that was just proof the physics could be beaten. The real question was, could they make it affordable enough for a $15,000 car? Here's where it gets wild. For the Model 2, Tesla didn't just reuse the Plaid's carbon fiber. They upgraded to a carbon-graphene hybrid composite, infusing the wrap with a 0.1 nanometer layer of the strongest material known to science. This single change pushes tensile strength to 10,000 megapascals and allows the motor to spin at 25,000 RPM. But raw speed is just the headline. What does 25,000 RPM actually do for you? The graphene layer cuts 30% of the motor's weight, dropping it from 45 kilograms to just 38 kilograms. Less mass means the motor uses less energy just to spin itself, consuming only 11 kilowatts to cruise at 70 miles per hour compared to 15 kilowatts in older designs. That's a 12% efficiency gain before you even touch the accelerator. But here's the real weapon: heat management. In EVs, heat is the silent killer. It's wasted energy. It's lost range. It's why your Nissan Leaf